Okay guys, so this is lesson 3, heating and cooling curves, and this is actually part 2 of the phases of matter lesson, which was lesson 2. Our objectives for this lesson are to identify and label all of the parts of a heating and a cooling curve. I have a guest with me today, Mr. G. I won't say his name, maybe we'll figure out his voice later, but he's going to help us out. So let's start with heating and cooling curves. The first one we're going to look at is a heating curve. And what happens when we're looking at a heating curve is that we're actually adding heat to a substance at a constant rate. So it has to be temperature versus time. Now remember, temperature is the average kinetic energy. So if temperature is increasing, so is the kinetic energy. So we're going to fill in our chart here according to our graph. And this is the warming curve. It's called endothermic, which we are going to talk about in lesson 4. But endothermic means to absorb energy or take in heat energy. So notice how boiling point and melting point are already labeled on our graph, okay? When we get to the point where liquid starts to turn to a gas, that's boiling point. And when a solid begins to turn into a liquid, that would be the melting point. And we know that we have fixed temperatures for water, but every substance has a specific melting and boiling point. And those are on table S in your reference tables. So let's start with section A. So Mr. G, tell us, how many phases do we have in section A?
There's only one phase, solid.
Yes, one phase, and that would be the solid phase. Very good. Okay, do you see a change in temperature?
Yes, temperature is increasing.
Yes, so it's increasing. Okay, so if the temperature is increasing, what's happening to the kinetic energy?
The kinetic energy is also increasing.
Okay, so there is a change. And remember, this little symbol here is a delta, and that means a change, okay, which equals change. So if there's a change in whatever we're looking at, we'll see that delta sign. So yes, it is increasing. So if potential or if kinetic energy is increasing, what's happening to the potential energy?
The potential energy is not increasing, it stays the same.
Okay, so it will remain constant. Very good. Okay, so how about, that's really sloppy. How about section B? So now we're looking at a plateau here. What's happening there?
At section B, there are two phases, solid and liquid.
Okay, solid and a liquid. And I'm going to abbreviate that. So how's temperature?
Temperature is not increasing.
No. Okay. No change in temperature. So therefore, is there a change in kinetic energy?
No.
No. And so how about our potential energy?
Our potential energy is increasing.
Okay. And do you want to explain to everyone what's actually happening there since there's a plateau? Or do you want me to help you?
You can help me.
Okay. So at the plateau, what's happening here, since we don't have a change in temperature, our kinetic energy can't change. Only one type of energy can change at a time. All right, so if one's not changing, then the other has to be. In this case, our potential energy is increasing. The energy is being stored up to change into the next phase, which would be all liquid. So let's go to part C now. How many phases?
At part C, just one phase, liquid.
And it's all liquid at that point. Okay, and is there a change in temperature?
Yes.
Yes. We're going up on an incline here, and so then is there a change in kinetic energy?
Kinetic energy increases.
Okay, so it's the same thing as section A, and then again, potential energy?
No.
No, very good. Stays the same. All right, how about D? Now we're going to go up.
At D, there's two phases, liquid and gas.
2, liquid and gas. Very good. Change in temperature?
No.
Nope, remaining constant. Kinetic energy then
Stays the same.
remains constant since there's no change in temperature, and our potential energy
It increases.
is increasing. Yes, increase. Very good. Okay, and last section. E, all the way up at the top.
Only one phase, gas.
Very good. Okay, and is there a change?
Temperature increases,
Yep, increase.
and kinetic energy also increases.
And how about potential energy?
Potential energy remains constant.
Okay, so there'll be no change. Stays the same. Very good. Okay, so now let's look at the opposite. We're going to look. Okay, so let's look at a cooling curve now, and this is actually going to be the opposite. My guest had to leave. He had to go to class, so Mr. G is gone. Goodbye, Mr. G. So let's look at the opposite. Now we're going down. Over time, heat is being taken away, cooled at a constant rate. Okay, so basically if you put something in the refrigerator or the freezer, it's going to be cooled at a constant rate. So over time now, basically everything's kind of going to be the opposite. So on the other diagram, which we looked at before, we have these two fixed points. Okay, this is going to be on this one the condensation point. Okay, that is actually when our gas is going to start turning into a liquid, and usually that occurs when you're taking a shower and you end up seeing all of those droplets of water on your mirror because the air is cooling or the steam is cooling from the shower and then leaving condensation on your mirror. Now finally at this point here, our other fixed point, this is going to be the freezing point. Okay, since we're cooling, eventually we'll get to a solid, so that's the freezing point. All right, so let's look at section AB. We're going down now. So we have one phase, that's gas. Okay, change in temperature, yes, it's actually decreasing. Okay, so then kinetic energy, yes, is changing and decreasing as well. Potential energy will not change. Remember what I said before, if one type of energy is changing, the other does not. It remains constant. So no, remains constant. So for section BC, now is a plateau, and we're at condensation point. So at BC we have two phases, and we also have, now we have liquid and gas. Okay, temperature is not changing, so neither is the kinetic energy, but the potential energy is, and it is increasing. It's being stored. Okay, so for section CD, again, one phase, we're at a decline here, one phase, and that's going to be all liquid at this point. The temperature is decreasing, and so is the kinetic energy. Therefore, potential energy does not change. DE, section D to E, is a plateau, so we have two phases there. We're going to have the liquid and solid. Okay, temperature is not decreasing, it's remaining the same, so we have no change, and therefore no change in kinetic energy, but the potential energy is, and it's increasing, it's stored. So the last section, you have one phase, and it's all solid at this point. Now you are completely past the freezing point and have all solid. So yes, temperature is decreasing, kinetic energy is decreasing, okay, and the potential energy does not change. And that actually sums up everything for heating and cooling curves. What I'd like you to do is try to do some practice on pages 4 and 5. Actually 4 we're doing in class, but 5 you can do on your own now, and you're going to be drawing out your cooling curve and answering questions related to that curve. Remember, heat is being removed for a cooling curve. That's why it's called a cooling curve.